So we're looking at using matrix to solve simultaneous equations. We have the simultaneous equation 3x minus 4y is equal to 1 and 7x plus y is equal to 23. So we are going to change it into matrix form. How do we change it into matrix form? We take the coefficient of this equation, the coefficient on the left-hand side of this equation, which is 3 minus 4, and also the coefficient of the left-hand side of this equation, which is 7 and 1. We put it in a bracket. Then we multiply it by the column matrix of x and y. And we equate it to the product, the solution, the result, 123. 123. We put it in a column matrix as well. So now the idea is that what we are going to do, we are going to make whatever we are using to multiply this column matrix to become an identity. And since as an equation, whatever we are doing to the left-hand side, we equally do it to the right-hand side. So I am going to make this particular one. I'll find the inverse of this particular function, multiply it by this, and it will give me an identity, because we know in matrix, the inverse of a matrix times the matrix is going to give us an identity. So what we are going to do now, we are going to get the inverse of this matrix. And how do we get the inverse of the matrix? The inverse of a matrix, A inverse, is equal to 1 all over the determinant of that matrix times the adjoint of that matrix. So we are going to get the determinant of this 2 by 2 matrix, and we denote that as this. The determinant of the 2 by 2 matrix now is going to give us, we multiply like this, 3 times 1, and 3 times 1, we're going to have 3 times 1 minus 4 times 7. So when we multiply 3 times 1, we are going to get 3. Minus 4 times 7 will give us minus 28. We multiply minus 28 by minus 1 here. That will give us plus 28. So that will give us plus 28. And that will give us 3 plus 28 will give us 31. So that is the determinant of this particular matrix. Since we've gotten the determinant now, we are going to get the determinant. We need to get the adjoint of that particular matrix. Now the adjoint of the matrix now is denoted like this. The adjoint, what we do is that we're going to interchange this particular diagonal. This one will go up, this will come down, then we multiply this other diagonal by minus 1. So that will give us 1, 3. Then I'm multiplying minus 4 by minus 1. That will give me plus 4. I'm multiplying 7 by minus 1. That will give me minus 7. So now this is now the adjoint. This is now the adjoint of this particular matrix. This is now the adjoint of this particular matrix. So what I'm going to do next now is for me to get my inverse. So my inverse now will now be equal to 1 all over 31 into 1, 4 minus 7, 3. Now, this is the inverse of this particular matrix. That is the inverse of that particular matrix. So I have gotten the inverse of the matrix. Now I am proceeding so that I can get my equation solved. So that is the inverse of the matrix. So I am going to use this inverse now. So I told you that we are going to use the inverse to multiply the both side of it. So I am going to use this inverse now, which is 1 over 31. So it's going to be 1 over 31 into 1, 4 minus 7, 3 times the matrix itself, 3, 7 minus 4, 1, then into xy. Then we are going to do that same thing here on our right hand side. 1 over 31 into 1 minus 7, 4, 3 times the column matrix, which is 123. So I am done with that. So I've done with that. So what I'm going to do next is If I am multiplying the inverse of this matrix by the matrix itself, it's going to give me an identity. And the identity now is going to be 1, 0, 0, 1 times xy times xy. Then all I need to do is to have this multiplied. I'm going to use this to multiply everything I have here. I'm going to use that to multiply everything I have there. So when I multiply everything I have by the matrix, I am going to multiply everything I have. So by the time I multiply everything I have here, this times this, this times this, this times this, this times this, and I multiply this matrix by this column matrix, I am going to arrive at 1. I am going to arrive at 1 over 31 into 9362. 9362. Then 1 over 31 times 93 will give me 3. 1 over 31 times 93 will give me 3. That will give me 3. And 1 over 31 times 62, that will give me 2. So I am going to have this. And being that this is an identity matrix, if you multiply it by an identity matrix, it is going to give you that same result. That's why we call it identity. When we say something is an identity, that means it doesn't change the result. So if I'm multiplying this particular column matrix by this identity, so the result will still be the column matrix, which is x, y. That will still be the result. So now if you look at what is actually showing here, what it simply implies that the elements are corresponding. So my x will now be equal to 3 and my y will be equal to 2. So that is how to solve a question of that sort.